This video will introduce the basics of exponential functions. Some key things that we're going to discuss are growth versus decay, the domain and range, the location of the asymptote, and what I've called the leading coefficient. This shows you a graph of kind of a generic exponential function. The general form of an exponential function is y equals a times b raised to the x, and then plus or minus k. I'll explain what each of these letters means. I'll start with b. B is what's called the growth factor. B is going to determine how quickly or slowly the function grows. Growth factor should not be confused with the growth rate. The growth rate is actually going to be the growth factor minus 1. The next variable we'll talk about is A. A is the initial amount if you're talking about a word problem. It's also, you'll hear me call it the leading coefficient. It's really important to realize that A is not actually part of the base of the exponent. It's only B that is being raised to the x. A is just multiplied with the result. So if you were evaluating, you would raise B to the x, then multiply by A. And in some cases, A can also be the y-intercept. But that's only when we don't have a k. I'm about to explain k. K is going to tell us where our asymptote is. At this point, you should be used to seeing a plus or minus at the end as the y translation. And as I have explained before, that will also cause the asymptote to move. When you look at an exponential function, one of the first things you always want to identify is if it's a growth function or a decay function. Basically, that means as time goes on or as the x values get bigger, is our function growing or is our function decreasing? And what's going to determine that is the value b. When b is greater than 1, we will have growth. And when b is between 0 and 1, we have decay. You will never see b less than 0, and you will also not see b equal to 1. If b equaled 1, we actually didn't have growth or decay. So let's look at what these graphs would actually look like. In a growth situation, you're going to see, as you go from left to right, you're going to see the function getting bigger. In a decay situation, as you go from left to right, you're going to see the function getting smaller. Notice, however, in both graphs, we have this nice curved shape. So here are a couple examples. In number 1, you'll notice that the 2 is my A and the 4 is my B. In all of these examples, we have a plus 0. There's no K, so we'll just sort of ignore it. So since B, which is 4, is greater than 1, I know that number 1 is going to be growth. Now in number 2, I have 2 times 0.02 to the x. The 2 is my A, the 0.02 is my B. So since B is less than 1, I know I have decay. So this graph would look like that, whereas the first one looked more like this. Now please notice I did not multiply 2 times 0.02. It is extremely important that you do not multiply A and B together. And then in number 3, I have a fraction. I have 2 times 3/4 to the x. But I can see that my fraction 3/4 is less than 1. 3/4 is less than 1. So again, I have a decay situation. So now let's look at why this actually happens. I've set up two tables here, one for a b less than 1 and one for a b greater than 1. And I'm just going to plug in my x values and see what happens to my outputs, which are these here. So these are sort of my y's, my outputs. We'll see what happens. Now you may not remember negative exponents, and it's not super important that you do, as long as you can still use a calculator and do 0.5 to the -2. If you were to do that, you would actually see you get a +4, -1 would be a +2, 0, 1, and 1 would be 0.5, 0.25, 0.125, and then 0.0625. So as you can see, as my x's increase, my y values are getting really, really, really small. They're actually getting super, super close to 0. As we keep going, they'll get closer and closer to 0. As a side note, this is what causes our asymptote. But also important to notice is that they're getting smaller, and that is why we have decay. Now looking at the other situation, if I do 2 raised to the x, again, negative exponents you may not remember, not a huge deal as long as you can use your calculator. So 2 raised to the -2 is 0.25, 2 to the -1 would be 0.5, 0, 1, 2, 4, 8, and then 16. Now you can see as x's increase, so do my y's. So this is going to be growth. If you think about it, if I take a number bigger than 1 and multiply it by itself a lot of times, well, of course, that's going to get bigger. But if I take a number less than 1 and multiply it by itself a lot of times, it's going to get much, much smaller. All right, now let's take a look at that k value. Again, we've already had some experience with k as it moves the graph up and down. And just as a reminder, when that k is on the right side of the equation, I got my x here, on the right side of the equation, the sign and the direction the graph move are actually going to match. So you can see 3 graphs here, the black being my parent function, and the red goes with 2x plus 3, so it went up 3 units. And then the blue goes with 2x minus 1, so it went down 1 unit. So k is really just going to tell you what the asymptote is. In the red graph, you can see there's a +3 there, so we know my asymptote is going to be at 3. And you're often going to see the asymptote given as a dashed line. In the parent function, the black graph, there is no k, so it's really a +0. So it's here at the x-axis. And then in the blue graph, I have -1, so my asymptote is at -1. And just another reminder, that's what's going to affect the range. So I'm going to write the range in here of each of these graphs. We know our parent is 0 to infinity. The blue is going to be -1 to infinity. And then this red graph is going to be 3. Oops, that should be red. Is going to be 3 to infinity. That's a +3 to infinity. +3. And just as a reminder, those are all the ranges. The domain of all of these is all real numbers. All right, so now for homework, I want you to identify 6 things about each equation listed here. So first, state if it's growth or decay. Second, state the growth factor. Remember, that's just b. 3, state the growth rate, which is going to be b minus 1. 4th, the asymptote. 5, the domain, and 6, the range. And I've done an example here for you. So if I had y equals 2 times 3 to the x plus 2, I have growth, because 3 is bigger than 1. My growth factor is 3, since that's b. And then my growth rate is 2, since that would be b minus 1. My asymptote is at 2, because of the k value. My domain's all real numbers, and my range is from 2 to infinity. All right, good luck.